Okay, in this video, I'm going to continue with my discussion of strategies for analyzing data containing missing values using the MPLUS program. So basically, we're carrying out a structural equation model, and we have cases that have missing values on different variables. And so in my first video, I discussed the use of list-wise deletion. My second video reviews the use of full information maximum likelihood estimation in order to estimate model parameters. And then in this video, we're going to continue this by looking at the use of multiple imputation. And basically, multiple imputation involves generating new data sets that contain imputed values for those cases that had missing values on the original variables. So for instance, I could create 10 data sets with imputed values, or 20 data sets with imputed values. So I start off by actually creating imputed data sets, and then from there I analyze the data in the next step, where basically we compile the information across the multiple data sets to generate an overall set of parameter estimates and standard errors and significance tests. So what I have open is just a Word document that contains some syntax that I've written in order to walk through the various procedures in carrying out multiple imputation and then analyzing the data sets with multiple imputation. So first off, the first step in this process is generating the imputed data set. So I have in this first line, I've just got title and then a name. So that the title command followed by sort of a descriptor here of what we're going to be doing. I'm going to be doing a path analysis ultimately, but I need to generate data sets with the imputed values substituted for the missing values. So then the next line, we've got data colon, and so that's the data command. Then file is, and then you've got the location of the data set that we're working with. Our data is actually in a CSV file, and I show you how to obtain that CSV file in my previous videos addressing list-wise deletion and full information maximum likelihood estimation. So at any rate, this is the name of our file, and then our file extension is CSV. And then this is essentially, showing you how to get to that file. So this is the path leading to our file. All right, so we end that line with a semicolon. Then I'm using the variable command and then giving names to all the variables that are appearing in this original CSV file in the order in which they appear. So the columns that are containing the data for each of the variables in this file right here, we want to match those columns up with the variable names. So I've got names are, and then the actual names that I'm providing. So then we follow this up with a semicolon, make sure that we have that in there. And then we have the missing option. So we say missing are all. And in this particular case, the reason why this matters is because all of the variables that I have in the data set, I've essentially assigned a missing value code of 999. So I want the program to recognize when there is a missing value on a variable. And so inside the parentheses, I've laid out 999 because that's well outside the bounds of all of the possible values on those variables. And so, so inside the parentheses is just basically saying we want the program to recognize 999 as a placeholder for a missing value, then followed by a semicolon. Then we have the data imputation command, and so next we'll type in impute equals, and then the names of the variables that we're going to be imputing values for. So the variables that we have in here are social conservative beliefs, economic conservative beliefs, trust in government, liberal conservative political identification, and income level. We're going to follow that up with a semicolon at the end, and then we have in data sets. And so this is essentially instructing MPLUS to generate a certain number of data sets with imputed values. So I'm asking the program to generate 20 data sets. Then we're going to follow that up with a semicolon. The next line is also very important. It's the save line. And so this is essentially providing it's instructing the program to save 20 data sets. They're going to be enumerated, but basically they're going to have this part right here, the actual ANES binary DV part. The asterisk right here is indicating essentially it's going to be enumerating the data sets, and then .dat, which is essentially the new data sets are going to be in DAT file format. It's also going to create sort of a master DAT file that essentially is going to be containing sort of pointers to the actual 20 data sets. Next, we have analysis type. So analysis command followed by a colon, then type in type equals basic semicolon, and then I just added this additional output option or command here, just output colon tech 8 semicolon. So once the program has generated the imputed data sets, then what we're going to do is we move to the next step, which is the analysis of the imputed data set. So the new data file is actually going to be this right here. And so you'll see it says file equals ANES space binary DV list. That list component that you see right here is the name of the master file that's going to contain the pointers to all of the individual imputed data sets. So when we put in this asterisk right here, that's what it's going to be. That's one of the files that's generated. So then we have that type equals imputation semicolon, then variable, then colon, then the names for all the variables they're going to be in our data set. And it says use variables. So the use variables command, we want to have the variables that we really specified up here is going to incorporate the imputed values. So we're going to use those variables, analysis command followed by estimator equals ML for maximum likelihood, semicolon. Then we have our model command and then lay out the basic path model. So we have trust in government being regressed onto social, economic, conservative beliefs, and political identification. Then political identification being regressed onto income level, social conservative beliefs, and economic conservative beliefs. And then I've also added in output command with tech 1, tech 4, semicolon. And then I also asked for standardized estimates. So that's what the stdyx semicolon command is going to give us. So let's run our analysis with, based off of this syntax. So I'm actually going to just copy it. I'm going to open up MPLUS and file new, and I'm just going to just paste this in. Just keep in mind too that your lines can't be more than about, I think it's 90 characters. So if you have a line that's exceeding 90 characters, the program starts to truncate things, and so then you end up with various error messages, and sometimes can be a little bit tricky to figure out what's going on. So if you do get error messages, that would be one candidate source of a problem. So I've got all my syntax listed, and at this point I'm just going to click on the run. So and it says save changes to MPText3, and so this is just a new file, so I'm just going to click on yes, and I'll just click on save right here. And so now you can see it's generating the imputations, and so then we have data sets 1 through 20. So there you go. So now with our output file, you can see we get a little warning message. Again, this is just because I have some variables in there with names that are longer than 8 characters, and it's just saying, hey, the program's truncating those. So there's not going to be any material problem with the output or anything like that. So summary of analysis, you can see the number of replications requested completed are 20, which is what we had asked for. We have just various information based off of we have missing data patterns and so forth as a result. So now let's take a look at our file right here, and in this particular case what we have, you can see that now what we've done, you can see each of the ANES binary DV DAT files, and you can see the enumeration. So there's the first imputed data set, the second one, the third one, the fourth one, and so forth, all the way down to 20. Then we have the master file, which is this one right here, where it says ANES binary dvlist.dat. So that's the mastery file, or the master list, as you can see. If we wanted to just take a quick look at it, we certainly can. I'm just going to open it up in a notepad, and so you can see it's just given the names of each of the imputed data sets. So that's it right there. So that's why that particular list is right here. That's why that particular file name is right here when we run our actual analysis. So at any rate, now we're ready to carry out the basic analysis of the multiply imputed data sets. So I'm just going to copy this as well, and I'm going to paste this in here, and I'm just going to save over what I'd done before. Click on Run and Save, and there you go. So now we have our analysis. So now kind of scrolling down, again we get our little warning message because our variable names were on the long side. As we scroll down, you have the sample statistics. Notice it's saying these are average results over 20 data sets. So there you go. And then scrolling down, we have the model fit information that's presented. So you can see with this particular output, the chi-square test, this is a chi-square value, degrees of freedom, and our p-value. So based on the chi-square test, the goodness of fit test is not significant. That would be one indicator of good model fit to the data. We have the RMSEA right here. The estimate is 0.015, which is clearly indicating a good model fit to the data. Scrolling down, we can see the TLI and CFI. Both of these values are well above 0.9, and so these are both indicating good model fit to the data as well. And then the SRMR is also indicating good fit. The model results, you can see we have our unstandardized path coefficients for the model. So these are the actual estimates, standard errors, z-values, and then p-values for two-tailed tests. So these are all largely the results are pretty much mirroring the previous video, the analyses from the previous videos. So I'm not going to go too far into really talking about that, but that's where the unstandardized results are, or that's where they are. Then we have the standardized model results as well, and so these are now can be interpreted in the form of standardized path coefficients, their standard errors, z-values, and p-values. Just kind of looking at going up to diagram and viewing the diagram, we have the basic model as I've kind of shown you before. The default is using the unstandardized path coefficients. If I go to view and click on the standardized estimates, then I can get the standardized path coefficients. So that's basically the approach to carrying out multiple imputation in MPLUS. Like I said, the basic idea behind this is that we generate multiple data sets that are going to contain their original values, but for the where there are cases where there are missing values, it performs an imputation, and essentially with those multiple data sets, the next step is essentially sort of carrying out the analysis over all of the, or compiling the information from all of the individual imputed data sets, and that then provides an overall set of results. So that pretty well concludes this discussion.